Welcome back to The Explainer. Today, we're diving into a massive dual narrative that is absolutely shaping the future of the aerospace and defense industry. We're going to unpack exactly how this colossal sector is preparing for a low-carbon future up in the air, while at the exact same time bracing for geopolitical supply chain shocks down on the ground. To do this, we're relying directly on the official disclosure metrics from these SASB standards. Let's get right into it. Here's our flight plan for today. We'll look at the dual aerospace challenge, dive into greening the skies, shift down to securing critical materials, and finally wrap up with true industry sustainability. We're essentially splitting our journey today between the incredible innovations happening in the air and the gritty realities down on the ground. Kicking things off with Section 1, the Dual Aerospace Challenge. This perfectly frames the monumental task manufacturers are facing right now. Okay, let's dive into this. Solving the modern aerospace puzzle literally requires balancing two critical fronts. On one side, you've got the airborne challenge, right? Fuel economy and emissions in the use phase. Manufacturers are under immense pressure to help commercial airlines and government fleets slash those greenhouse gas emissions. But on the flip side, we have the ground level challenge, material sourcing. You just cannot build next generation highly efficient vehicles without incredibly specific, often rare raw materials. It's a real balancing act. The industry has to achieve both vehicle efficiency in the sky and supply chain resilience on the ground. To really understand how these companies are actually measured on these two fronts, we are grounding our entire analysis today in the official SASB Aerospace and Defense Sustainability Accounting Standard. These standards, which are now part of the IFRS Foundation, provide the exact metrics that investors and regulators use to see if a company is truly prepared for the future or, if they're just lagging behind. All right, moving to Section 2, greening the skies. Let's look up and see how companies are actively pushing technology to lower carbon footprints when these vehicles are actually in use. Now, greening the skies isn't just about good PR. It is fundamentally about business survival. Capturing future market share depends entirely on how well manufacturers can adapt to changing customer preferences and strict regulations. The standard points out that, yes, many of the industry's products are powered by fossil fuels and release greenhouse gases. But because they design and manufacture the global fleet, these companies have this total unique opportunity. They're the ones who can actually help other industries and government agencies hit their own climate goals. So to meet that massive demand, companies are investing heavily in entirely new propulsion architectures. We're talking fully electric, plug-in hybrid, and zero emissions tech like fuel cells. We aren't just talking about making standard jet engines a tiny bit more efficient here. This is a total rethink. The metrics require companies to explicitly describe their R&D efforts into these advanced technologies, plus their partnerships with academic institutions or governmental customers to actually bring them to life. But hey, it's not just the engines, right? It's the energy that powers them. We are talking about a massive shift to renewables, covering sources that can be replenished quickly. Think biomass, which includes ethanol and advanced biofuels, along with solar, wind, geothermal, and hydroelectric power. What's absolutely fascinating is this huge push toward hydrogen fuel cells. Get this, hydrogen packs nearly 3 times the energy of standard jet fuel by weight, and it operates on alternatives like natural gas and methanol. Companies actually have to disclose their total revenue from the sale of these alternative energy-related products. Which brings us to how manufacturers actually track and prove these improvements year over year. To measure inherent fuel efficiency improvements, they don't just rely on one metric. For ground vehicles and marine vessels, they look at classic miles per gallon. But for aerospace vehicles specifically, the industry standard is this measurement called 1 divided by specific air range. I know, it sounds like a mouthful, but simply put, it just measures how much fuel is burned per unit of thrust over a specific distance. By tracking these exact metrics, investors can see precisely which companies are successfully greening their fleets. Okay, let's shift gears to Section 3, securing critical materials. We are moving from the limitless possibilities of the sky down to the hard physical limitations of the Earth. You probably hear the term critical materials thrown around a lot, right? Well, the SASB standard strictly defines a critical material as one that is both essential in use and subject to the risk of supply restriction. Emphasize that "and" in the middle. It's not just that the material is important, and it's not just that it's hard to get. It literally must have both high operational importance and high supply vulnerability to make this list. Basically, if you don't have it, you can't build the product, and getting it in the first place is incredibly risky. Now, what's really interesting here is that these specific elements are the absolute bedrock of advanced aerospace manufacturing. We're looking at antimony and cobalt. You've got platinum group metals like palladium and iridium. And then you have the rare earth elements, things like yttrium, scandium, and the lanthanides like neodymium and erbium. These materials often have practically zero available substitutes. They're exactly what make advanced aerodynamic designs, lightweight structures, and next-generation energy storage batteries actually function. And because aerospace manufacturers often double as defense prime contractors, the standard highlights some very unique shortfall risks for defense-related applications specifically. We're talking about tin, beryllium metal, silicon carbide, bismuth, and chromium metal. A shortage in these specific materials doesn't just mean a delayed commercial flight, folks. It means a potential operational shortfall in national security applications, from space vehicles all the way to complex missile systems. So why are these specific materials so incredibly vulnerable? Well, these supply chains are threatened by four major forces: physical limits, unavailability, massive price volatility, competing global demand from other sectors like consumer electronics, and, perhaps most importantly, geopolitical uncertainty. The intense reality here is that many of these rare earth metals and critical elements are sourced from only a handful of countries. If geopolitical tensions rise or trade policies suddenly change, an aerospace manufacturer could find themselves entirely cut off from the one single material they need to finish an aircraft engine. Talk about a bottleneck. Because the stakes are so high, companies have to disclose exactly how they're managing these risks. The standard guides us through 4 exact mitigation strategies for surviving these supply shocks. First up, diversification of suppliers, so not relying on just one country or one mine. Second, the physical stockpiling of materials to create a buffer against sudden shocks. Third, heavily researching and procuring alternative materials, basically trying to engineer the vulnerability out of the product entirely. And fourth, making serious investments in recycling technology to reclaim these critical materials from end-of-life products. That brings us to Section 4, True Industry Sustainability. Let's finally merge these two fascinating narratives together. Throughout this explainer, we've seen how the standard demands total transparency on 2 totally interconnected fronts: sky innovation and ground resilience. The absolute core takeaway here is that building a revolutionary, lightweight, zero-emissions aircraft means absolutely nothing if you cannot safely and reliably source the rare earth metals required to build its advanced electric engine. True sustainability for this sector, it requires winning on both the engineering front and the geopolitical front. Which leads us to a final provocative question for you to ponder. Can we truly achieve green skies without resilient chains? The data strongly suggests they are completely inseparable. Climate innovation and global supply chain security are just 2 sides of the exact same coin for the aerospace industry. Thank you so much for joining me for this explainer. Keep asking the right questions, and I'll see you in the next one.